All right. This is from the year 2014, question number 6 from the APCalcBC test. And we went over these in class on Tuesday and Wednesday when the juniors were taking their ACT and work keys test. So I just want to go over all three of these again. So if any missed them, you can kind of catch up on that. And like I said, you can find them on the College Board website too. That's all from the APCalc test. And they have the solutions there also. But just if you need an explanation to go with the solutions, that's what these videos will have. So we're going to start here, 2014 question 6. And it seems like the Taylor series question is always the last question on the test. That's certainly the case for this test. If you look back at the last few years, that seems to be the case. So let's take a look at this one. We have a Taylor series for a function. They have this phrase here about x equals 1. It's kind of a throwaway phrase. It doesn't mean too much. It just means when you look, they have this shift. They didn't make this at 0, they made it at 1. And you can tell because they have an x minus 1 and an x minus 1 squared and x minus 1 to the nth power. So this part here is not going to be real important in the problem. It's just for consistency that they're telling us that. But we could have seen it, like I say, right here. You could notice that already. So we won't get too hung up on that x equals 1 part of it. All right, so we've got that. And they tell us it converges to f of x for the absolute value of x minus 1 less than r, where r is the radius of convergence. And now they want us to find this r, or find this radius of convergence. So let's take care of part A. How do we get a radius of convergence? Well, there's x's in here, clearly. And when there's x's in a series, you have two choices. Is it geometric or the ratio test? And if you look down here in the bottom, actually first look at the top. That's to the nth power. This is to the n, or n plus first power. That's to the nth power. It seems like it might be geometric. And in this guy right here, that little n on the bottom, it's not to the nth power. So this is not geometric. So this will be the ratio test. And even if you always did the ratio test, it would work. It's just for geometric, you don't need to check the endpoints. But this one we will, except they want the radius. So I guess in this case, we don't have to check the endpoints either. Let's take the limit. As n goes to infinity, we've got the absolute value, and I put in n plus 1. So I have negative 1 to the n plus 2, because n plus 1 plus 1. I have 2 to the n plus 1. I have on the bottom n plus 1, and I have x minus 1 to the n plus 1. Now I'm going to divide by the nth term, and why don't I just immediately multiply by the reciprocal? So on the top I have the n, and the bottom I've got a negative 1 to the n plus 1, and I've got a 2 to the n, and I've got an x minus 1 to the n, all inside the absolute value. And so this unfolds like a typical ratio test. All right, can we cancel anything out of here? Let's just extend that page a little bit, not quite that much. Can we cancel anything out of here? And hopefully you say the answer is yes. There's one more 2 on the top, so I'll reduce and have a 2 up here. There's one more x minus 1 on the top, so I'll have that x minus 1. It's a little sloppy, but that's a minus 1. We'll fix that later. On the top, the negative 1 to the n plus 1 and the negative 1 to the n plus 2, I can reduce by negative 1, but it's inside an absolute value, so a negative 1 isn't really going to even matter inside absolute value. So I can just ignore that completely. And so as I simplify this, I'm getting down to, I have a 2, I have an x minus 1, and I have this n over n plus 1. All right, we are taking the limit. N is going to infinity. So I look over here at this n over n plus 1. I get infinity over infinity. I use L'Hopital's, and I get 1 over 1. So I'm left with the absolute value of 2 times x minus 1. Looks like that, inside that absolute value. I look back up at the, or maybe I'll factor out the 2. Sorry. I get the absolute value of x minus 1. I look back up at the question, and I notice that they have it written as x minus 1 less than r. I know when I do the ratio test, this ratio should be less than 1. So if I solve for the absolute value of x minus 1, I'll get less than a half. So that would be my r value. My r would equal this half. If you wanted to go a little bit further and actually get the interval, you could. You go negative 1 less than 2 times x minus 1 less than 1, and you could solve this as well, you will still end up with a radius that equals a half. So kind of in class, we kind of spell out that interval because we're checking the endpoints, and you could do that as well. But either way, you get 1/2 for the radius. All right, that is part A of this question. We are on our way to a 9 points on this question. All right, second part. Find the first 3 non-zero terms and the general term of the Taylor series for the derivative, for f prime, the derivative of f about x equals 1. And again, at about x equals 1, it's nothing that we really need. It's that throwaway phrase. It's just saying, hey, we made this at 1, which we can kind of tell. All right, just so we can keep the question on the screen, I'm going to take this part and erase it. And let's just start with a clean screen here, just a little bit. So now we're doing part B. And let's just scroll back up so we have the full question on here. All right, part B. First 3 non-zero terms and the general term for f prime. Well, maybe I should write out some of these terms, and maybe I'll just sneak it right in here. When n is 1, I'll put in a 1. I get -1 squared. I get 2 to the first over 1. And I get x minus 1 to the first. When n is 2, I will get -1 to the third. I'll get 2 to the second over 2, x minus 1 squared. And when n is 3, I will get -1 to the fourth, 2 to the third over 3, x minus 1 to the third. And let's simplify that a little bit on the next line. It looks like a 2 times x minus 1. Looks like -2 times x minus 1 squared. And it looks like plus 8/3 x minus 1 to the third power. All right, they are asking me for the derivative, f prime of x. So I just come through and I'll take that derivative. And we can label it anything we want to go f prime. We're not going to write the infinite series, so we could say it's about these first 3 terms. So I come here to this 2x minus 1. I take that derivative, and that derivative is 2. I come to the next term. I'll use my power rule. I will get negative, just take off that plus sign. I will get minus. I will get 4 x minus 1 to the first power. And then one more derivative with the third term. The 8/3 times a 3 gives me an 8. And I get x minus 1 to the second power. And that looks pretty darn good. Those are my first 3 non-zero terms. Then I come back and say, oh, wait. They also wanted the general term of the Taylor series. So I have to come back up to our general term up here, erase a little bit of that. And our general term is up here. Right there is our general term. I need to take that derivative. So I'll go plus, dot, 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 plus. And we'll take that derivative. When we do, we notice -1 to the n plus 1, that's a constant because we're taking the with respect to x. 2 to the n is a constant, n is a constant. So all of those factor through the connect with multiplication. So I get -1 to the n plus 1. I get 2 to the n, all over n. That all comes through. Then I take the derivative. And it's just a power rule. I go n, x minus 1 to the n minus 1. And at this point, you could reduce a little bit. The n's cancel out. Not necessary, but you might as well. And so I get my general term is -1 to the n plus 1, 2 to the n, and x minus 1 to the n minus 1. So there's my general term. Make that hopefully a little clearer. There's my general term. There's my first 3 non-zero terms, and maybe we'll just kind of highlight that so we have both of those parts. All right, that takes care of part B. Again, things that we've learned how to do, not too bad. All right, part C, I would like to actually keep part B up here. Part C, they tell us the Taylor series for f prime about x equals 1 that we found in part B is a geometric series. Let's look at this again. Here's a 2, -4 times x minus 1, 8 times x minus 1 squared. they're right. That is geometric. If it's geometric, tell me what A is. A is 2. What's the ratio? What are they multiplying by? They're multiplying by a -2 and an x minus 1. If you're not sure, look at the nth term. Look, everything is to the nth power, or n plus 1 or n minus 1, same difference. And we get a -1 and a 2 and an x minus 1. So that kind of makes sense. That's our r. Okay, so we've got that. Find the function f prime for which, here we are. Find the function f prime to which the series converges. All right, that means find the sum. Yeah, what is the sum of the series? What does this equal? It equals a over 1 minus r. So our series, let's see, we don't have, so f prime converges to, so we could just say f prime. Now we can say equals, if you want, a over 1 minus r. So we get that. And again, we might as well simplify a little bit. So we get 2 over, if I distribute that, I've got a positive 2, I have a 2x. And I get a -2 and a +1, so I get 2x minus 1. And that would be the series that this converges to. That's for f prime. Now, using this function, they would like us to come back and find f. And this is where this starts to get tricky. Hopefully say, okay, so far I get this. This is f prime, what we just found. Can you guys come back and figure out f? Hopefully your answer is yes. I would just take the integral. If that's f prime, give me the integral. That would be f. So let's take this integral. We're going to take the integral of 2 over 2x minus 1 dx. Either do it in your head or do a quick little u to u. U equals 2x minus 1. du is 2 dx. Look how nice this is turning out to be. That'd just be the integral of 1 over u. And the integral of 1 over u is natural log. So I get the natural log of the absolute value of 2x minus 1. And don't forget that plus c. Come back to the original part. Did they give us any kind of an initial condition? Come way back up to the beginning, to the original question. Let's erase all this stuff one more time. So did they give us any initial condition? Not really. But if you look a little closer, oops. If you look a little closer, if x equals 1, and I sub in the 1, I just lost the board there for a minute, but now we're back. I'm sorry for that delay. So if x equals 1, and that's not where I wanted my line anyway. If x equals 1, and I sub that in right there, x equals 1, so I have my function at 1, I can see 1 minus 1 is 0. All my terms would be 0. So I could use this initial condition. When I put it, since it was about x equals 1, when I put in a 1, 1 minus 1 is 0. All my terms are 0. And so my initial condition is f of 1 is 0. So here's my function. F of x equals this natural log. But when x is 1, my function should equal 0. And you can check that out, but that will lead to your constant equaling 0. So my final answer for the final part of part C is my function would be the natural log of the absolute value of 2x minus 1. And that takes care of 2014 question number 6, probably one of the trickiest questions on the AP Calculus exam. So hopefully that all makes sense.